So very good morning guys. Well, today we'll see the various operations of circular linked list. We'll see about insertion and deletion in circular linked list. Insertion at the beginning, at the end, deletion at the beginning and deletion at the end. So this is the first program in which we will be inserting a new node at the beginning of circular linked list. So what is the main difference between circular linked list and single linked list is that in circular linked list the link part of last node should contain the address of first node. So this makes it circular, right? So we'll write a program for insertion of a node at the beginning of circular linked list. Okay guys, so tell me what is the theoretical concept of this. So what we do first, we will first create a node. We will create this node. Let's suppose the info part is 40 and let's suppose the address of this is 400 and let's suppose this is PTR. Now once we create this node, we will try to insert this node at the beginning of my single linked list. Take a circular in beginning of my circular linked list. So if this node will be the first node of a linked list, and the link part here, it should contain the address of first node, which is 100. So it should contain 100. And one more change will be required, and that change is that the last node, the link part of last node should contain the address of first node. Since this will become my first node, so this should contain what? This should contain 400. So what we will have to do, we will have to make three changes. First, we want 100 here, right? Second, the link part of last node should contain 400, and the third change is that the first pointer should contain the address of very first node of circular linked list, right? So let's start programming this. Okay, let me create a very small function, void create, void insert underscore single linked list, right? So tell me guys, what all addresses are important here? See, one address, this 400 is important, and which we will get once we create a node, and the link part of this will change it to 100. So this 100 is also important. 100 we will get from our first pointer. So 100 is available with us, this 400 is available with us, but what is not available with us is this 300, because I am going to change the link part of this 300 to 400. So the addresses which are important, which I want to target, is 400, this 300 and this 100. So how many pointers you basically require? See, you require one pointer to create this node and one pointer to traverse that to the end of your circular linked list. Fine. So we'll be requiring two pointers. So let me take two pointers. Struct node star PTR and one, let's suppose, star CPT. Fine. So let me create this node, and how you create a node, as you already know, we use memory allocation function to create the node. So that is nothing, you have to basically typecast first. It's struct node because malloc returns a void pointer, so that need to be typecast to your struct node star. Then your malloc size of, how much size is required? Size of your structure is required. So size of struct node. So once you write this and you assign the address of this will result in what? This will point to the address of your newly created node 400. You want to assign this 400 to your PTR, which is, now this 400 gets assigned to your pointer variable PTR. So now the value of PTR becomes what? 400. Now your PTR is pointing at 400. Right, now you want to insert the info part, so you can write it as scanf %d comma address PTR arrow info. As you already know that info is member, you cannot access the members of structures directly, they can only be accessed by using the pointer variable or the structure variable. So PTR arrow info, so I will input that as 40 here, so this value becomes 40. Right, the next thing which is important, I told you already in my previous session that the block which is empty right now, you have to first fill this. And what I want in this, I want 100. And what is the value of 100? This first is my value of 100. Right, so I will insert in this 100. How? And this part is what? This part is basically link part of this PTR. So PTR arrow link, and I want the value 100 here, and 100 is nothing but the value of your first variable. So PTR arrow link is equal to 100. So here it comes 100. So this gets connected to this. Fine. Now my second and the most important thing is I want to target this address 300. So what I will do, I will start traversing from this 100 and I will reach till the end. And how will define that this is the end? This end denotes that the link part of this node should contain the address of first node. So I have taken a pointer for this. So what I will do, I will assign that pointer to the address of very first node. So I will write CPT is equal to first. So right now my CPT points to 100. So this is my CPT right now. Right now I want to move from 100, then 200, then 300. So what I will do, I will simply run a loop that while CPT arrow link. Now this do not contain a null because it is a circular link list, so we will have to compare it with the first. So CPT arrow link not equal to first, you keep on incrementing your pointer. CPT is equal to CPT arrow link. So let's see how this works. So currently the value of your CPT is 100. Fine. So here we are checking length of this 100. Length of this 100 is 200. So 200 not equal to 100. The condition is true. So CPT is equal to CPT arrow link. Now your CPT moves to 200. Right? So 200 length is 300 not equals to 100. Condition true. Your CPT moves to 300. Now 300 arrow link is what? 100. So 100 not equal to 100. Condition becomes false and you will come out of loop. So at this point of time, your CPT is pointing at 300. Fine. Now, since this has become your first node, right? PTR this becomes first node, and this right now the CPT is pointing at the last node. So you know that in a circular link list, the link part of last node should contain the address of first node. So my first node is 400, which is nothing but your PTR, and link part right now it is containing 100. So instead of 100, I want what? 400. So what I will do, I will simply write CPT arrow length is equal to 400, and 400 is nothing but the value of PTR. So you will write CPT arrow length is equal to PTR, right? So this becomes your last node. CPT arrow length is equal to PTR. CPT arrow length is equal to PTR. So यहाँ पे आ गया 400. So this gets connected to this. So this has become your last node. This has become your first node. So as you already know that the first pointer should always point to the very first node of a linked list. So you want to break this connection and you want the value of first to be what? 400. You want this connection like this. So you want the value of first to be 400, and the 400 is nothing but your PTR. So what you will do, you will write first is equal to PTR. That's it. So I'm again repeating. So what is the main difference between circular and single linked list? That in circular linked list, the link part of last node should contain the address of first node. There is no null here, right? Now we want to insert a node at the very beginning. So let's suppose we will create this node and we want to insert the node at the very beginning. So the link part of the newly created node should contain the address of next node. Since this will become the next node if this is first. So this link part should contain what? 100. So here PTR arrow link is equal to 100. 100 is nothing but the value of first. So you will write PTR arrow link is equal to first. So here it is now 100. So this gets connected to your second node. Now you want 400 here. The link part of last node should contain the address of first node. Since this is your first node, so it should contain 400. So now what I have to do, I have to take a pointer and I have to traverse that pointer till the end of my circular linked list. So for that I need a pointer CPT. I have assigned that pointer to the address of the first node so that it can traverse further, because we are not going to move this pointer. We will take the address of this first pointer to some other pointer and we will traverse that pointer, not the first pointer. Because I keep in mind that the first pointer will always point to the very first node of a linked list. So CPT is equal to first. So I keep on moving the pointer till the last. So I have already told you that this is a set code which makes sure that the pointer points to the last node. But in this, there is no null, so you will compare it with the first, because link part of last node should contain the address of first node. So while CPT arrow link not equal to first, CPT is equal to CPT arrow link. So you keep on forwarding your pointer till you reach till the last node. So after this piece of code, your CPT is pointing at 300. Now what you have to do, you have to change the link part of the CPT to with the newly created node, and the address of newly created node is 400, and 400 is nothing but your PTR. So in link part you want 400. So CPT arrow link is equal to your PTR. So CPT arrow link is equal to PTR. So 400 comes here. So this gets connected. So this node gets connected to this node. Now since this has become your first node, you know that the first pointer should always point to the first node of a linked list. Initially first was pointing at 100. Now you want your first to point at 400 because this has become your first node. So 400 is nothing but your PTR. So you will write first is equal to PTR. Thank you so much guys.